This video is on GTViewer Expressions and the Expression Playground app that is part of the GTViewer add-on app bundle version 3. So what's an expression? Think of it as a mathematical formula where you compute a value from other values, variables, and functions, all strung together with operators like plus, minus, multiply, divide, etc. GTViewer uses three types of expressions. The first type tests for true or false. Is one thing equal to another? Is one thing greater than or less than another? And so on. The second type of expression is used to compute a value, which is usually used as parameters in the 20+ functions supported by GTViewer Expressions. The third type of expression is used to manipulate text or strings for creating labels, names, or tooltips. This is the most commonly used expression in GTViewer, and most of the available functions deal with text or strings. So where does GTViewer use these expressions? They're in a lot of places, some of which you may not know about, so I'll quickly run through most of them. Dynamic graphics uses expressions to determine which features to highlight or label. It creates the label with an expression, and it can map an expression value to a color for highlighting. Feature tooltips use expressions to build a string to display as the tooltip on a feature, and the string can use the feature's attribute values. Proximity search uses an expression to build a string to display as additional information for features found in the search radius. It can also use expressions to customize the feature name in the results. Picklist names use expressions to create alternate feature names to display when a picklist is needed or on the right mouse menu. Attribute info names use expressions to create alternate names for the attribute info dialog title. Where Am I uses expressions to create the name and description of the polygon found containing the clicked point. Detail links use expressions to create URL links by building a string that can utilize attributes from the selected feature. GTViewer is not the only app that uses expressions. GTechLoader uses expression for filters, groups, and style names. The Oracle Loader uses expressions to define most properties since it doesn't have metadata like the GTechLoader does. Keys, angles, filter names, style names, labels are all expressions. GTShareViewer can use expressions to filter the records for display, and can use expressions to filter the records exported to various formats. I don't want to overwhelm you with all the uses of GTViewer Expressions, but I wanted to show how much they're used and how understanding them will help you. There's also a tool called the Expression Playground. It's part of the GTViewer add-on apps bundle version 3, and it gives you a place to experiment with GTViewer Expressions. You can interactively create and test them, and you can see how your expressions will behave before ever putting them in a configuration setting. Go to the Applications menu in GTViewer and select the Expression Playground. The top box on the form is where we enter our expression. And an expression is just our numbers or variables with operators, either adding them together, subtracting them, comparing them, whatever we want to do. But let's start with something really simple. I'm going to say 12 and say evaluate. Well, there's no operators to do anything on it, so a 12 is 12. We could say 12 times 3, get 36. We could say 12 times 3 plus 13, 49. We could also use parentheses and change our order of operation. I'll put it around 3 plus 13, so it'll be done first, and we'll get 192. We can put a division in there after we're done, and we can keep going as much as we want. It's just basically computing the math behind what we've entered in for the expression. And as well as the results in our result area here, we also get the return type, which in this case it's a double, and whether or not the expression was valid or not. If the expression's invalid, then it will give us a reason as to why. Let me put something in that doesn't make sense, and it will give me an error. And see, it tells us that it's invalid, and it's showing us approximately where the error is. The next type of expression used by GTViewer is to determine if something is true or false, and you can use operators like equal or not equal, less than, greater than, less than equal to, greater than equal to. You can also use logical operators like and, or, and not. Let's go through a few of these. I'll enter something simple to start with here. 100 is less than 50, and I'll press evaluate. That gives us a 0. That means false. 0 is false, 1 is true. And you'll see 100 is not less than 50. If we flip this the less than around to be a greater than and reevaluate, it gives us a 1. We can also combine these with logical operators like and or. So if I say 100 is greater than 50 and 75 is less than 25 and evaluate it, that gives us a 0, because while the 100 is greater than 50 is true, the 75 is not less than 25, and they both have to be true because it's an and. So it gives us a false. If we change the and to an or and reevaluate, then it's true because only one has to be true. This also works with strings, not just numbers. We can say, I'll put ABC as a string and say, is it equal to DEF? When I evaluate, that gives a no. These are not the same. So I can say ABC equals ABC and evaluate it, and that's true. And string comparisons are not case sensitive. So if I changed one to ABC capital case and evaluate it, it's still true even though they're different cases, because it doesn't care about the case. This also works with less than and greater than. So we could say, is A greater than B? That gives us false because A is less than B. Let's flip that around and reevaluate, and it gives us a 1. And it's also not case sensitive. So if I said capital A is less than B, that's still true. The last type of expression GTViewer uses is the one that creates strings or text. Let's run through a few of those. Let's say ABC again and add that to DEF. When we evaluate it, we get the two strings added together to form ABCDEF. If we put a space in there in one of the strings, we could get it. We could also have said add a space by itself. That gives us the exact same thing. We can also use functions with strings. There's an uppercase function called upper. I'll put that around our string that we're adding together and evaluate, and that makes it all uppercase. There's also some other functions like pretty. I'll give it a string that's not very pretty and run it. This takes all the capital letters and makes each word capitalized instead of the whole word. There's also modes on pretty. It defaults to mode 0, which is the make the first letter uppercase. If we changed it to a 1, it's going to remove the underscores. And if we change it to a 2, it's going to do both. It's going to remove the underscores and capitalize the first letter of each word. Now, you may wonder how I know all this. I know it because I've done it many times, but there's also suggestions as we're typing into the expression line. You'll notice when I just type the P or PR, it's showing me anything that matches in the available functions or variables. And in this case, pretty is the only thing that matches. And it's telling us that it's a function and that it takes two parameters, a source string and a mode, an optional mode. If we scroll over a little bit, it tells us what the modes are. 0 capitals the first letter of each word, and 1 removes underscores, and 2 does both 0 and 1. And it also says the default is 0. Now, you can press tab, and it always completes whatever the item is in your suggestion. So we could say, I'll just put a dummy string in here. And in that case, all it does is capitalize the A. The example expressions I've shown so far have been trivial. To really see how you can use expressions, you need to have variables, and the Expression Playground provides a couple of ways to do this. The bottom portion of the form shows the variables you have to work with. We can create our own variables with the set command like this. On the expression line, we say set. We give it the name of a variable. I'm going to use pi equal to and either a value or another expression. I'm going to say 3.14159. When we press the evaluate button, you'll see our new variable pi has been added to the variable list, and the value that it's set to is shown in the results. These are called user variables, and they're just for testing, and they always appear as orange, and the values are always blue. If I use our pi value in an expression, it works just like the value I've assigned to it. Let's clear that out, and I'm just going to type in pi and evaluate it, and it comes out as 3.1459. And since it's a value, we can do other operations with it. I'll multiply it by 2. Let's add another variable called radius and set it equal to 25. Now let's use a real formula. I'll do the circumference formula, which is 2 pi r, so I'll say 2 times pi times radius and evaluate that, and here's the circumference of a circle with a radius of 25. The set command is just for the expression playground to help with testing. GTViewer uses the feature's attributes as the variables, and we can select a feature in the map to load all of its associated attributes into the variable list. I'll select a primary conductor in the map. Here are all the attributes loaded in as variables. Variable names are always formatted as the table name, dot, and the attribute name. Here's all the primary conductor tables, here's work order table, here's connectivity table, and all the attributes. The feature attributes are always in black, and at the bottom there's a set of green attributes that are metadata attributes from the selected feature. And these are items like category name, filter name, feature number, feature name, and so on. When you start the expression playground, it's automatically in feature selection mode until you select a feature. If you want to select a different feature, press the Select Feature Mode button and select another feature on the map. This time I'll select a pole, and the pole attributes are loaded into the variable list. Variable names always start with a square bracket, so the suggestions know you're going to be using a variable once you type the opening bracket. You can start typing in a variable name and press the Tab key to use the first suggestion in the list. Well, let me demonstrate. I'll clear the expression line, and let's say we want to do the poll number. So I'm going to type an opening bracket, and as I start typing the word poll, it's only showing the poll attributes. If I say dot and poll, another P for poll number, that's as much as I need to get it in the top of the list, so I can press a tab and it completes it. If I press evaluate, it just evaluates and gets me the poll number. We can also go back to our empty line here and say poll, and this shows us all of our poll variables. I can also double click on one and it will complete it. I'll evaluate that and get the poll height. There's still a couple more ways to get variables into the expression line. Let me clear it again, and we can use the list of variables at the bottom. So let's say I want ownership. I can double click on that. It's just like double clicking on one in the suggestions. But there's also a even more powerful method here. Let's say I wanted the poll number. I'm going to right click on it, and it gives me 4 options. I can just paste in the variable up there. I can say plus in the variable. I can use the alternate name from the database information plus the poll numbers variable, or I can add the poll number alternate name and the poll number variable. So I don't have anything in the line, so I just want poll number and the variable. It sticks it right up in there. So I'll press evaluate here, and it put the poll NO colon in there, and that's coming from this alternate name right here. Now we can add more information. Let's go back and add the height. I'm going to right click on it. This time I already have something on the line, so I want to do the plus height and poll height. And I'll evaluate that, and now we have the height. And then we can add something else. Let's add ownership and evaluate that, and we very quickly can build us a line of information without typing anything. There are some basic rules that you need to know when using GTViewer Expressions, and I'll go over those next. First, let's talk some more about variables. I've already talked about variable names being in square brackets, but this is actually not required unless you have special characters or spaces in your variable names, but it's probably a good habit to get into, and it lets the suggestions know what you're trying to do. For example, I can say poll ownership with the square brackets, evaluate that just fine. I can take off those square brackets, and it also works just fine. It's kind of hard to see that since it doesn't change. Let's do it one more time. I still get the same value. There are some GISs that use spaces or other special characters in their table and attribute names, and in those cases the square brackets are required. And I'll just quickly demonstrate that. I can say set poll number with a space, let me use a capital N, equals 1, 2, 3, 4, 5. And this works just fine. And I can use that variable with the space in it however I want. It still evaluates to the same value. Now if I take those brackets off and try to evaluate it, it gives me an error. It doesn't really know what I'm trying to do. It thinks I have two variables, poll and number, and no operator. So it errors out. Now it did create me two temporary variables, poll and number, but that's just part of it being incorrect. Let's do one more with a special character. I could say exclamation point valve num equals 321 and evaluate that. And this works fine too. There's the 321, and if we look right here is our valve number with an exclamation point at the beginning. I will, let's clear that out. I'll double click the valve num and evaluate it, and I get 321. Now when I take away the square brackets here and evaluate it, it's going to give me true. That's because the exclamation point is also the not operator. You can say NOT for not, or you can say an exclamation point. It thinks that you're trying to do a not on a valve num that it automatically defines and sets to a blank, which is a 0. So not 0 is true, or not false is true. So it's not what you want. And so you have to put the square brackets if you've got special characters. We just saw that variables don't have to be defined in GTViewer to use them. If the variable is undefined, it will just be set to a blank string value. You might think this is odd, but it's so you can define one expression for several features, and if a particular attribute is not in one of those features, it isn't going to error out. It just behaves as a blank, and you can handle that however you want. Let me go through a few examples of this automatic variable creation. I'm going to clear everything out. I'm going to clear my previous variables. And let's say I just type A. And all it does when I evaluate is it creates us a temporary variable here, or a user variable called A, and it sets it to a blank value. I can say A plus B. Still works, doesn't error out. It created two variables, or the A was already there. It created the B, set it to blank. And I can set one of those variables to a value, and it works just like it did before. And then I could say A plus B. It's going to still give me 1, 2, 3 because B is blank. Now, as I said, GTViewer will always default undefined variables to blank, and you'll notice there's an option here. You can turn this option off, and it will make you have a variable defined before it can be used. And this is sometimes useful for when testing your expressions, because let's say you didn't have the data that you were working with and you wanted to make sure that everything was as you thought, all the variables that you typed in were actually there, because if you mistyped one, it would just create it as a blank and not cause any problems. So I've unchecked this. I can evaluate this now, and it's still going to work because these were defined earlier. If I clear those out, and let's try to do the same thing. I can do A, it's going to give me an error. I can do A plus B. It's still going to give me an error because they're not defined. If I check this back on and evaluate, it added both of them, A and B, and set them to blank, and worked just fine. So now let's look at an example of this that might be more useful to you. Let me clear everything out. I'm going to select a poll. Let me go to select mode and pick my poll. These features have a IPID attribute, an item of plant ID. So I'm going to find the IPID. There it is. And I'm going to evaluate it just to show you that it works. And this is from a poll. Now, not all features have an IPID. If we pick a different feature that doesn't have one, it's just going to be set to a blank value. But how do we use this to our advantage? Let's make this expression a little more complicated, and I'm going to go down to the bottom of our list here, and I'm going to put my cursor at the beginning of the expression, and I'm going to add the GTI feature name. And I'm going to add a dash and an IPID colon and a space, and then I'm going to leave my work order IPID there. And when I evaluate that, it says poll IPID. Now, I'm going to find an intersection here. There's some intersections here, these little eyes. And I'm going to select one of those. An intersection does not have an IPID. If you look at our values there. If I evaluate this again, it tells me it's an intersection and it says IPID colon, but it just leaves a blank. It doesn't error out. And while this works fine and may be what you want, we can make it not show this dash IPID colon at all if there's no IPID defined. And to do that, we use a function called IFFUNCT, IFFUNCT. This is like the same function in Excel if you've ever used it in Excel. So I can say IFFUNCT, and what it does is the first parameter is an expression that evaluates to true or false. So my expression is going to be this work order IPID. I'm just going to cut and paste, put it there, and if it's not equal to blank, which means it's populated, the next parameter is what it's going to return. So this is where I'm going to leave my dash IPID colon work order IPID. And I'm going to put a comma, and our third parameter is what it returns if the expression evaluated to false. So I just want it to return to blank. Hopefully I have that typed in correctly, and I'll evaluate it again. And you'll notice the IPID goes away. It just says the feature name, which is intersection. Let's go back to the poll right here. This is a different poll, but it doesn't matter. And I'll evaluate that. And here we have poll and an IPID. And let's pick something else. Here's a primary conductor. I'll evaluate again, and here it says primary conductor and gives it an IPID. And it also prevents errors. So if you did have something wrong, it wouldn't cause any problems for your users. The next topic is data types. I briefly discussed this earlier, but there are some important things you need to know about them. GTViewer Expressions support 3 data types: integers, doubles, and strings. However, all of the attribute values that you load in from a feature are strings, no matter what they originally were. I'll select a poll on the map and load its attributes in, and you'll notice that all the data types in the far right column here are strings. And like I said, it doesn't matter what they were to start with, there'll always be a string here. Now let me find a numeric value. Poll height's numeric. I'm going to add that to our expression here and evaluate it, and it says it's 40, but you'll see the return type is string. If we wanted to use the poll height in some kind of criteria where we're determining if a poll's over a height or under a height, we could say poll is less than 25. This doesn't work because our variable is a string and our value on the right side of our less than sign is an integer, and you can't compare integers and strings. Like you would do in a programming language, you must cast the string variables to either an integer or a double before you can use them as a number. And there are 3 cast functions available: toInt, toDouble, and toString. This is an integer, so we can convert it to an integer. I'm going to put my cast function around it, toInt, put my parenthesis on the other side, and evaluate it again. And it says false because our 40-foot pole is not less than 25 feet. So it's false. Let's flip that around just to make it true. So our 40-foot pole is greater than 25. I'm going to select another feature on the map. This time I'm going to select a primary conductor, and I'm going to use its length attribute because it's a floating point number here, so I'll use a double type. So let me clear out our expression here, and I'll just add our length there, and I'll evaluate it, and it's 521.26592. Now, even though that looks like a decimal value, it's really a string, as it says here in the return type. So let's again do our same little experiment here. If it's less than 500, evaluate it. It isn't going to work because it's a type mismatch. You're comparing a string to an integer. Since this has a floating point value, I'm going to use the toDouble. and evaluate it. And this time it says false. It's 0 is false, and that's because our length is 521, and that's not less than 500. If I flip our sign around and evaluate it again, it's true because 521 is greater than 500. Now we could use the toInt function. I'm going to say toInt. I'm just going to take off our condition there, and let's see what we get when we run it. It just gives us 521. If you do a toInt on a floating point value or a double value, it's always going to round it. It's either, if it's over 0.5 or above, it's going to round up, and if it's less than that, it'll round down. So 0.26 is less than 0.5, so it rounds down. Now our other cast function is toString, and any of the numbers can be converted to a string. So let's take a number like, let's say 123, and we're going to evaluate that. Now it's giving me 123 back, but it's a string. That's text now, so we could add it to whatever we would like. I'll evaluate that again and just appends it onto it. So it's all string values at this point. While we're on the topic of strings, let's go over some of the rules associated with them. Now a string can be a literal. We can just type in any string we want and tick marks, and evaluates as a string. You can use double ticks as well, or quotes. They work the same way. What you can't do is mix the single and the double ticks together. If I do that, it'll give us an error, missing quote. Now you can mix the different ones together in the same expression like this. That's perfectly fine. Some of the tricky things here are, what if you need a quote or a single tick in your string that you want to create? You can always use the opposite quotes around the one that you want to use. Let's say I wanted to say 12 feet with a tick mark. I can start with a double tick, use a single tick, and then close with a double tick, and that works just fine. Let's say we wanted to do 6 inches. I'd start with a single tick, 6, and a double quote, and a tick, like that. And if you need to put those together, I would just do 2 separate literal strings and add them together. 12 foot 6 inches. Also with strings, there's a special token for carried return line feed. This is useful when you're creating tooltips with the tooltip builder, because a string can be multiple lines for a tooltip, and the only way to tell it to go to the next line is with a carried return line feed. Let me just quickly illustrate that. Let's say we have a string ABC plus DEF, all one line. Now if we put our carried return line feed token in there and reevaluate it, it becomes 2. And you can just keep going on with this. Let's say carried return line feed, and so forth. A lot of things don't support the multi-lines, but tooltips do, and you almost always have multiple lines in a tooltip because there'll be more than one attribute that you're showing. The next topic is functions in the GTViewer expressions. There are 20 plus functions available right now, and most of them are for string manipulation. I've used some of the functions in the previous examples, but I wanted to go through some of the more common ones just so you know what's available and how to use them. Let's set up some variables to work with. I'm going to set a equals to ABC and then put 3 spaces after it and create that variable, and then I'm going to do set a B to 3 spaces before DEF and 3 spaces after, and evaluate that. Now when I add those together, I'll highlight the whole line so you'll see there's spaces between them and there's spaces after. There's 3 different trim functions. There's LTrim for the left, RTrim for the right, and just a trim that trims on both sides. And that's usually the one I use. So if I say trim A, but do nothing to the B, see, it got rid of some of the spaces. It got rid of all the spaces after the A, the 3 spaces after the A. Now there's still the 3 spaces before the DEF because it has before and after. But I can say trim on it, and all the spaces are gone. Another thing that's common to do is formatting your floating point or double values. So let's clear that out. Let's select a pole so we'll have something real to work with. Or let's pick a primary conductor because it has a good floating point value in length. So I'm going to take that length value, which is 521.26592, and let's say we don't want all of those decimals printed. Now there's a function called format that helps you do this. So I'm going to type in format, and let's look at the format in the suggestions just because it shows all the parameters. The first parameter is the number that you're wanting to format. The width is the minimum width that it will take up, and that includes the decimal point, the points after the digits after the decimal, and the numbers before. And precision is the number of digits after the decimal place that it's going to show, and that one's optional. Let's take our conductor length. Let's say we want to make it a minimum of 5 and with 2 decimal points. Well, this isn't going to work because this is a string, and it'll tell you that it has to be an int or a double. So we need to do our cast to double. And I'll reevaluate it, and there we go. It's formatted to 0.27, 2 decimal places, and 5 wide. Now, this string is actually 6 wide, so the 5 is just the minimum. I'll change this to 10, and let's see what it does. It's going to make the whole string be 10 characters, and that's the minimum. If it gets larger than that, it'll go beyond it. And the 2 decimal places are the 2 to 7. If we change this to 3, then we'll get 3. But it's still within the 10 character limit. There's a few other string functions I'd like to show. Let's clear that off, and let's clear everything out here, and I'll create a new variable, str equals bcdef, just so we'll have something to work with. There's one function called INSTR, INSTR, and if we look here, it takes a string, a search string or substring, and a starting position, which is optional. And what it does is it finds this search string, what position it is in the string. So we could say str is what we're looking in, and let's search for just CD. And I'll evaluate that, and it gives me back a 2. So how do we get 2? This is a zero-based list of positions. So the A is 0, the B is 1, and the C is 2. And that's the start of CD. So it starts at position 2. Let's search for something that doesn't exist. There's no Z's in our source string. So I'll evaluate that. It returns -1. That means that it's not present in the string. And this is not case sensitive, so it doesn't matter what case our letters are. Opposite of that is substring, SUBSTR. And it takes a source string and a starting position, and then it will take an optional length on how much of the string to return. So let's say substring of our str variable and say 2. And that's the starting position is 2, which is where the C was. It takes from the C and the rest of the string, so it skips the first 2 letters. We could also add let's say another 2 on there for the length, and it's just going to do 2 of those letters after the starting position, so CD. And let's do replace. That's another popular one to use. And it takes a source string and a search string and a new string to replace the search string with. If I take str as our string, and let's say our search string is BCD, and we're going to replace it with a space. And it took our BCD out and just put a single space there. We could also say an empty string, and it will just remove the BCD. Or we could change our search string to df, and let's change our replacement string to XYZ. And evaluate, and now we've got ABC XYZ. I'll show one more just to kind of give you some variety. You can also say the length. And length takes the source string and gives you a number value return for how many characters are in it. So if I do length of str, it's going to say 6. And then this is a number, so you could do whatever you want with it. There are several others that I'm not going to go through, but they're all documented, and you can always use the suggestions. As long as it's clear, you can search through all of them and see how to use them. And if you need more information, there is documentation, and it gives more examples on each one. One feature I haven't talked about so far is the explain. This is really a debugging tool that may or may not be useful to you, but I quickly want to demonstrate it just so you'll know it's there and that you can use it if you need to. I'm going to paste in a fairly complex but still fairly trivial expression just so we can see what it does. This is just a bunch of less thans, greater thans, and ands and nots. I'm going to do an evaluate. It says it's false. What if some of these were variables and we didn't really know what the values were, and you wanted to see how that data was flowing through this expression as it was being computed? Once you have a successful evaluate, you can always hit the explain button. And it brings up another form, and it shows you your expression, and then it breaks it down according to how it was processed. If you've got a conditional operator, like the ands or the nots or the greater than less thans, it's going to be green for true and red for false. And the value in parentheses are what it was computing at that point. Now, this is a tree view, and it's pretty simplistic. And if it doesn't give you enough information, there's also a record view, which gives you a lot of information. And I'll stretch this out a little bit so we can see it all. But let's go back to the tree view for a second. Let's just kind of look at this expression and see what's going on. So we've got 1 plus 2 is greater than 3 plus 4 times 5. So here's our 1 plus 2, the add, which gives you 3. Here's a multiply, which is adding 3 and 4 and multiplying by 5. So 3 and 4 were 7. I'll collapse that just to make it more readable. And 7 times 5 is 35. So we have an add of 3 and 35. And that is compared to, it has to be greater than the second part of the expression, which has a not. So it does the greater than first, the 35 on one side, and the divide by the 4 plus 2 plus 7, which is this number here, 0.85. So let me collapse that to make that clear. So you have to be, the 35 has to be greater than the 0.5. That's true, so it's green, but then there's a not in front of it, so that flips it around and makes it false. And our and says that both of these two clauses under it here have to be true. Neither one of them are, so it all boils down to false. Now, if you want to look at the record view, it's the same information. It just gives you a few more details for each step along the way. And it doesn't have the collapsibility to make things more readable. If you have a fairly complex expression or you just can't figure out why something doesn't work, you can always do the explain and then at least step through the process and see what's going on, because this is exactly what it's doing internally. The last feature I want to go over is the history. And if you look at the top right corner of the form, there's a history button, and this simply shows the last 20 unique expressions that we've tried to evaluate. It gives you the list. You may have to scroll down some. And if you pick one of these, I'll just pick one at random here, it plugs it into the expressions and you can evaluate it. This one's using primary conductor, so let me select a primary conductor and do evaluate, and then here's our formatted value with 3 decimal places that we did earlier. And that's pretty much all of the history. You do have the ability to clear your history, and if you decide you don't want to pick any of these, you can just hit the back button here at the bottom and it takes you back to the expression form. This has been a lengthy run through GTViewer Expressions and the Expression Playground, but I didn't cover everything. There's documentation on GTViewer Expressions which details each operator and function and all the rules, and you can use the suggestions list as documentation as well. The Expressions Playground was meant to get you comfortable creating and using GTViewer Expressions, and the more you know about how to use them, the more you can take advantage of GTViewer features like tooltips, dynamic graphics, proximity searches, and custom pick list. Thanks for watching, and go build some expressions.